To recap, the assumptions for the normal model really come down to two main ideas. According to the last video, you really want to make sure that you've met the success-fail condition. So we definitely want to check that NP is greater than 10 and NQ is greater than 10. So if you can verify that, you know that you can at least expect normal model. But you also are going under the assumption that you're going from binomial, and binomial goes back to Bernoulli trials and all sorts of other details. And if you really break that down, what you have to have for a Bernoulli trial is independent random events. So when you check for independence, then what you're looking for is, well, two things usually. Do you have a simple random sample? If so, then it's quite likely you have independence from one person to the next if everybody was randomly chosen. And you also want to check the 10% condition. So you want to check, is n less than 10% of the population? And a lot of times you don't know what the population size is, so you just make your statement regarding that. So let's take a look at an example, and then I'm going to have you guys try one. So we have 13% of the population is left-handed. A college class has got 15 left-handed seats, and we're worried about if we're going to have enough chairs. So this is on your handout. Try to follow along and pause as needed. And so we're going to start out by trying to verify that we have any assumptions needed to answer this question. Do we have a large enough sample? So let's check what is P in the first place. That's good to assume that this is P right here. So P times N is going to be 0.13 times sample size of 90. Is that greater than 10? So 0.13 times 90 is 11.7. Just barely made it. And I know it's obnoxious, but go ahead and check both to confirm that 1 minus 0.13 times 90 is also greater than this. And you can kind of do some shortcuts. Greater than 11.7, which is greater than 10. It's kind of obvious because you check the smaller one. So we do have a large enough sample. Double check, is n too large? Is 90 less than 10% of all students? And that seems like a logical yes. Sorry, my handwriting's so sloppy on the stylus. So it seems like we have independence. It seems like we have a large enough sample. And I think it's also safe to say that this college course would count as a random sample. So you can even throw in there like SRS is likely. So as we go through and start answering the question, we now can draw a normal model because we just verified it is going to be normal. We can label the center at 0.13, and we can try to figure out where is p hat in the story. So p hat equals, it looks like in this case, we're worried about 15 out of the 90, so we'll make that our sample proportion, 15 out of 90, which is about, I think, 17%. Yeah, roughly 17%. So the question we need to figure out then is where does that 17% land on the curve, and try to answer the question with probability. So let's figure, first of all, what is sigma p hat? We got the square root of 0.17 times not 0.17, so 83 over 90. Crunch that. Square root of 0.17 times 0.83 divided by 90. And we get 0.0395. So we'll do 0.04. So now we know that this 17% is, well, right at 1 deviation higher. And we can really answer the question with the 68, 95, 99.7 rule if we want. But we can go ahead and punch this in through normal CDF and confirm that the probability is really close to 16%. So go ahead and try that. Make sure you're getting around 16%, then try the next problem on your handout.